Hi everyone, my name is Youssef Saleh and today I'll be solving an IB past paper question from topic 6, paper 2. Here's the code of the question if you'd like to refer to it at any time. So the first part of the question asks us to define the rate of the reaction. And by the way, the question is worth 9 points. So 9 minutes. So we need to define the rate of the reaction. By looking at the equation, what can we write about the rate of the reaction? So that brackets right here represent concentration. The delta symbol represents change, and the R represents reactants, T time, and P for products. So the equation says that the rate of the reaction is the change in concentration of the reactants over time or products over time. And that's the exact definition: change of concentration of products or reactants over time. The unit for the rate of reaction is mole per decimeter cubed per second. Mole per decimeter cubed is the unit for concentration, and second is the unit for time. So right here we can realize that the equation is measuring the decrease of reactants over time and the increase in products over time. If the reactants decrease, that means the products increase. Because that's why there's a negative sign. Because the reactants decrease over time, it's going to be a negative value. Therefore, the negative value next to the change in concentration of the reactants turns the value into a positive value. Now, to solve the next part of the question, you need to understand what's the collision or kinetic theory. It basically states that the chemical reactions occur when particles collide. However, not all collisions successfully lead to reactions. Now we need to take a look at the factors that affect the rate of a reaction based on the collision theory, what we just took a look at. You get a point for each factor you list. So first of all, particles must collide, of course, for a reaction to occur. If we increase the rate of a reaction, that means that there is a higher frequency of collisions per unit time, meaning that there are more collisions for a certain time period. The second factor is that there must be sufficient energy for particles to overcome the activation energy. The activation energy is the energy needed for a chemical reaction to occur. As a result, particles must have enough energy to overcome the activation energy and for the reaction to occur and be successful. The third factor that affects the rate of a reaction is that particles must collide with correct orientation or geometry. This is also known as sterics. So now we have taken, or we have, now we covered the first 4 points of the question. Now for the next part. The next part asks us to draw two Maxwell-Boltzmann curves, that represent the same gas. However, one is at temp T and the other is at a higher temperature, temp T dash, or temp T apostrophe. So we get a point for labeling the correct axes, of course, and we also need to explain why increasing the temperature increases the rate of a reaction. That's the second part of this part of the question. So here's the Maxwell-Boltzmann curve we are asked for. Now for the correct axis, on the y-axis we draw the number of particles. We write the number of particles, and on the x-axis we draw the energy, or kinetic energy. So we get the sixth point for having for giving the curve the correct shape and making sure it doesn't touch the x-axis. That means that the curve will never reach at a high temperature, will never reach a point where the number of particles is 0 at a high temperature. Now let's look at the curves. So at temp T, that's the normal temp T curve, and the harder part comes when we draw the curve for the higher temperature, T dash. So what will happen is that we get a point for drawing the second curve. However, the peak of the second curve needs to be lower than the peak of the first curve, and it needs to be to the right of the first curve. Why is that? Because right here we see at this value of the kinetic energy, A high number of particles have this value of kinetic energy. However, since the temperature increases, the value of the energy increases where the number of particles, where the most number of particles have this value of energy, a higher value of energy. In general, all particles, more particles will be able to collide and successfully react more than the original temperature T. Therefore, the curve of the second or the higher temperature must also be flatter. And that's what happened here. So that's the correct shape. Now we need to explain why increasing the temperature increases the rate of reaction. So we know that temperature is the average Ke. So if we is a measure of the average Ke. So if we increase temperature, we increase the average Ke. Therefore, if we increase the energy, and that's a point we covered here, the factors that affect the rate of a reaction. If we increase energy, more particles will have sufficient energy to overcome the activation energy. Therefore, there will be more successful collisions per unit time. And these are all the points. So you get the fifth point for writing the correct axis, the sixth for the correct shape, making sure the line or the curves don't touch the x-axis, the seventh point for ensuring that the curve of T apostrophe has a peak lower than normal T and to the right of the original T. You get the eighth point for saying that increasing the temperature increases the average kinetic energy and more particles will have sufficient energy to overcome the activation energy. And the ninth or final point, more successful collisions per unit time. Thank you so much for watching. I hope this video has helped you.